User interfaces help your player navigate through your game. But how do we even get from our player pressing the start button to actually starting the game? And how do we even get that button there in the first place? In this tutorial, I'll explain how to use the control node to build UI, how container nodes help you organize and arrange UI elements, and after that, we'll go through a bunch of simple but fundamental examples like changing text, making buttons interactive, and how to use progress bars. My name is Mac, let's do this. In Godot, UI starts with this little green node called the control node. This node has some base functionality inherited by all other green nodes, so understanding how it works is really useful. So let's create a new scene with it. In this section, we'll open the layout settings and focus only on settings that affect the anchoring, sizing, and positioning of our elements. If we unselect the control node, you will see the viewport area. Its size can be found by navigating to Project and then Project Settings. In the new window, under Display, select Window, and then you'll see the viewport width and height on top, along with other useful settings worth checking out. When the control node is selected, it highlights an area in the scene view which I'd like to call the content area. The content area has a size and a position which can be found in the inspector. The position corresponds to the top left corner of the area, and it can be moved through the inspector or by clicking and dragging anywhere in the area. Keep in mind that in 2D, the positive x-axis is to the right and the positive y-axis is downward. You can change the size through the inspector or by clicking and dragging one of the red handles. Notice how some red handles also move the top left corner, which affects the position values. The green handles control what are called anchor points. You can find their values in the inspector if you set the anchor preset to custom. In the scene, anchor points are the invisible edges between the green handles. Each handle is in control of two edges, and when you move one, it doesn't affect the content area, but if you move an edge through the inspector, the corresponding edge of the content area moves along. To further demonstrate anchor points, let's use a color rect node, which is the same as a normal control node, except that it fills its content area with a color. Then we add another color rect node as a child, make it red, and rename it to child for some clarity. The edges of the anchor points stay in place relative to the content area of the parent node. When all anchor point values are 0, the green handles are in the top left corner of the parent's area. If we set them to 0.5, the handles are in the center, and if we set them to 1, the handles are in the bottom right corner. Instead of setting the anchor point values manually, the anchor preset setting allows us to quickly snap to commonly used values. This setting can also be found in the toolbar when a control node is selected. With the child node anchored to the bottom right corner of the parent node, notice that when we change the size or position of the parent node, the red node stays in place with that bottom right corner. Since the root node has no parent control node, its anchor point edges stay in place with the viewport. For example, if we use the anchor preset to snap our anchors to the bottom right corner and adjust our window size in play mode, our root control stays in place with the bottom right of our window. Now, instead of having all anchor points in the same place, when they are spaced apart, they cause a node its content area to grow and shrink along their parent area. For example, if we select our red node and match its green handles with its content area, watch what happens when we change the size of the white area. Container nodes are control nodes that take care of their child sizing and positioning. Once a node becomes a child of a container, all its anchoring and transforming properties will be disabled and grayed out in the inspector. Setting a custom minimum size is still available, but we will get back to that later. Let's start with the box container. A box container comes in two variants, horizontal or vertical, and arranges all its child nodes over an area in the selected orientation. So let's add a horizontal box container and give it a single color rect as a child. Before we can properly use any container node, we will have to do a little side quest first. And that's understanding how the container sizing settings work. Currently, you will see this thin vertical line on the left. It's thin because most containers take care of sizing their children depending on a few settings. With our child node selected, we can find those settings under layout and then container sizing or up here in the toolbar. If available, these settings take care of sizing the content area over a horizontal and vertical space. Sizing only happens if the expand flag is turned on. If there is no expand flag, like there currently isn't one under the vertical property, then it's turned on automatically. That's why the color rect we've just added is vertically stretched but horizontally isn't. When we leave the horizontal property to fill and turn on the expand flag, our color rect's content area also stretches horizontally. The other three values, also known as shrink flags, shrink the object down to its minimum size. Shrink begin tells the parent node to align this object with its start. So let's also set the minimum size of x to 100 to actually see what happens. Then shrink center aligns with its center, and shrink end aligns with its end. The same applies to the vertical property, but of course that would also require a minimum size on the y-axis. The stretch ratio property only has an effect when the expand flag is turned on, and if there is at least one more sibling node with the expand flag turned on as well. Let's put both properties back on fill, duplicate our color rect node using Ctrl+D, and make the duplicate have a red color. Stretch ratio determines how much space this node takes. If we set the stretch ratio of the left to 2 and leave the right at 1, the left takes 2/3 of the space. Again, this only works for all the control nodes within the container with the expand flag turned on. That's it for the side quest. Let's head back to the horizontal box container. I'll turn off the expand flags for this next bit. You might have noticed that the horizontal box container automatically takes care of the arrangement of the two nodes after duplication. And even if we add more, it keeps on arranging them. On the hbox container, in the inspector, we can also see an alignment property that lets us align our contents to the begin, center, and end. Then if we come down to theme overrides, under constants, you'll find separation. There's a 4 pixel separation by default, but we can make this any number we want. The Minecraft menu is a good example of where box containers could be used with these vertically stacked buttons and a constant separation between them. Now that you understand how the box container and its relation to the container size settings work, you should be able to quickly pick up on other container nodes like the flow container and the grid container. The flow container, also with a horizontal and vertical variant, arranges child controls in the selected orientation and wraps nodes around at the border, which is kinda like the moon collection system in Mario Odyssey. The grid container arranges child controls in a grid layout, useful to create inventory systems or character select screens like the one in Valorant. That's it for the containers. Now let's continue with building some actual UI. In games, you'll often see something like a timer, a score, the number of lives, or anything that has to do with a number on the screen that changes during gameplay. In game development, we use text fields to display both text and numbers, so the first thing we'll look at is how to change text through code. In a new control node scene called text changing examples, we'll start with adding a label node. The label node lets us display text on the screen. In the inspector, there are a bunch of settings, though I won't be covering every single one of them. In the text area, you can write down some text that will be displayed in our scene. You can add label settings to adjust the font and give it an outline or shadow. We'll just use it to increase the font size to 50. For this example, I want to change the text to something else upon pressing the spacebar. So let's start by adding a new script to the scene root. Now, in order to change the text, we'll need a reference to the node. A very clean way in Godot to make references to node is by making the name unique. First, right-click the node and select rename, or hit F2 with the node selected and change the name to some text. Then right-click the node again and select access as unique name. If all goes well, there should be a percentage icon next to our node. Lastly, drag the node into the script and hold Ctrl when you release it. This automatically creates a variable with a reference to the node using our unique name. In the process loop, we'll make an if statement that checks if we press the UI accept, which is a built-in keybind that refers to the spacebar and enter keys. In Godot, the text of labels can be accessed by addressing the text property. Address a variable some text first, and then its text property. Then assign it something like some different text in between quotation marks. Run the scene and hit spacebar to see if some text on the screen changes to some different text. Okay, that's pretty easy, right? Let's go for something more interactive in another example. In this example, I want to make a number increase by 1 each time we hit a key. So duplicate the previous label node and rename it to counter text. Also change the text to the number 0. Then I'm also going to put both labels inside a centered VBox container for some organization and center align the texts. Back in the script, create a variable with a reference to our new label. We also need a variable that keeps track of the counting, which should be of type int. Then we'll make another check, but this time for the up button on the keyboard. Inside the scope, write counter plus equals 1. And lastly, assign counter to the text property of the counter text. Writing this results in an error because different data types cannot be assigned to one another. Our counter is of type int, but the text property is of type string. Luckily, Godot has a built-in function that converts all sorts of types to a string. Just call the str function and pass in counter as an argument. In play mode, we should now be able to increase the counter by pressing the up key. And so you get this tiny UI game, which is basically cookie clicker. For my final text example, I want two labels to follow my mouse and show the mouse coordinates. So again, two labels, one named mouse X text, the other mouse Y text, and both accessible as unique. I anchor the X label to left wide and the Y label to top wide. If you want, you can give the label some dummy text like mouse X and mouse Y. Back in the script, drag in the labels, and then we are going to write 5 more lines. First, we need a local variable for the mouse position. We can get the mouse position through the viewport. Then we assign the mouse its X position, to our X label its global X position, and then we do the same thing, but then for the Y label. Lastly, we need to assign the text properties of both labels. Let's start with the X label text. We're going to need the str function again to create a string from text in combination with our coordinates. First argument, mouse X. Second argument, the mouse its X position. Then the same thing again, but for the Y label. If you hover over the scene in play mode, you should now be able to see our coordinates show up while also following our mouse around. And just to make things look cool, we can add a color rect node to both. For the color rect under the X label, I set the anchor preset to left wide and change the X size to 2 pixels. And then for the Y label color rect, I set the preset to top wide and make the Y size also 2 pixels. Upon running the scene, you should now have this nice crosshair that follows your mouse. Next, we will be taking a look at using buttons. There are many different types of buttons, but down to the core, they are all the same. You click one and it does something. And that's why, in this section, we will look at the core functionality of taking user input and using it to execute some code. For the upcoming examples, I'm using a new control scene called button examples that contains a VBox container node with center alignment, these layout settings, and a separation of 30. In this first example, we will create a simple button, and when we press that button, it changes some text. So start by adding an hbox container and call it press example. In there, we'll add a button called press me and a label called press me text. Remember that the parent container takes care of sizing its child node, so set the custom minimum size of the button to 100 by 100 so it becomes visible. Let's also give the button some text, like press me. Then change the text of the label to button was not pressed. Now for the programming part, technically we could add a script to the root node again and do the programming for the examples in a single script. But I feel like making a few small and simple scripts this time. So let's add a new script to the press example node. In order to make buttons work, we are going to have to use signals. And to understand how signals work, we will have to do another side quest. In Godot, think of a signal like a conductor's baton, aka the stick the conductor uses to give cues to the musicians to begin playing. In code, this is what a custom signal looks like, but many nodes like buttons have a list of built-in signals that can be found in the Node tab. Musicians know what part to play, but they wait for the conductor's cue to start. Similarly, a function connected to a signal waits for the signal to be emitted before executing its code. In code, you can connect functions to signals by calling connect and passing in the function name as a parameter. You can also connect a function to the built-in signals list. Right-click the signal, then connect, select the script you want the signal to connect to, and then click connect. This automatically creates a connected function with the signaling node its name and signal name, and it also creates this signal icon. Just like a group of musicians awaiting the same cue, multiple functions can be connected to the same signal. When the conductor gives a cue, the musicians respond by playing their parts. When a signal is emitted in Godot, all connected functions react by executing their code. In code, a signal can be emitted by calling emit. This is unnecessary for built-in signals because they emit automatically based on some event. Back to the example, let's connect the pressed signal of our press me button to our script. Then make the press me text accessible as a unique name and drag it in as a variable. Then replace the pass with the following line, which changes the text of our label to button was pressed. Now upon running the scene, when we press the button, the text next to it should change. Let's take a look at a toggle button. For this example, we'll be changing the text based on the button being toggled on or off. Let's copy the previous example and rename the button to toggle me and the label to toggle me text. Let's also change the text value of the button to toggle me as well and the text of the label to off. The pressed signal is still connected to the previous script, so disconnect it. We need to make a variable of toggle me text, so make it accessible as a unique name. On the toggle me button, look in the inspector for toggle mode and turn it on. Replace the script on the toggle example node with a new one. The toggled signal is passed with a boolean value that is true when toggled on and false when toggled off. Connect the toggled signal to the script and drag in the toggle me text as a variable. This time, in the connected function, let's use the provided bool parameter to change the text to on or off. Use an if statement with the toggled on parameter as a condition, and if true, we change the text to on, otherwise we change it to off. Run the scene again and test to see if the toggle button works. For my final example on buttons, I'll quickly show you how to make a button that loads another scene. You'll mostly want to use this to start your game or to load another menu. Let's use a copy of the press example and drag it to the bottom. Then I'll change the names of the nodes again for a bit more clarity and disconnect the old signal. Then let's change the text of the button to start game and the text of the label to a button that changes the scene, just to explain what the button does. Then replace the script with a new one. In the Node tab, connect the press signal to the script, and in the connected function, replace the pass with the following line: get3.change_scene_to_file. Then we need to pass in a path to a scene file. I'm going to use this main scene here that runs a character controller from a previous video. Right-click the scene file and select copy path. Then paste it in between quotation marks to pass the path as a string. Now if we run the scene, when we press the start game button, it should load up another scene. Lastly, let's take a look at progress bars. The progress bar is one of the most convenient UI elements to give information to your player. So you can think of HP bars, ability channeling, level progression, XP progression, and level loading. You probably get it. There are a lot of use cases for progress bars and they all come down to this simple basis. For the progress bar examples, I once again set up a new control scene called progress bar examples and added a VBox container to it. In this first example, we'll build a simple progress bar that can increase and decrease using two buttons. Let's first set it up. I'll start by adding an HBox container and renaming it to basic progress bar example. Then I'll add a button, call it left button, and change its custom minimum size to 50 by 50. Let's put a minus inside the text box. Then we can just duplicate this button and call it right button and put a plus inside the text box. Now in between, let's add the progress bar node. Then turn on the expand flag for the horizontal alignment and set the vertical alignment to fill. The progress bar has a few pretty straightforward properties. The one we'll be using the most is the value property. When you left click and drag that property to change its value, you can already see the progress bar making a visual representation of that value between the given min and max range. For my example, let's put the max value property on 10, then let's add a new script to the basic progress bar example node. First we need a reference to the progress bar, so let's rename it to basic progress bar, make it accessible as unique, and then drag it into the script. Next we need the pressed signals from the left and right buttons connected to our script. Then inside the left button press function, remove the pass and address the value property of our progress bar. Let's decrease this value by 1 each time the button is pressed. Do the same for the right button, but instead of decreasing the value, we increase it by 1. And that's already the basic progress bar. Upon running the scene, you should now be able to manipulate the value of the basic progress bar using the plus and minus buttons. Fun fact, you can use Windows emoji keyboard inside Godot to replace text with icons. When we go to our buttons, in the text area, press the Windows logo plus the dot key to open the emoji keyboard. Let's replace the minus with a finger pointing left and the plus with a finger pointing to the right. I'm a bit unsure if this would work on Mac, so maybe let me know in the comments. For this example, we'll take a look at how to build a progress bar that displays a time duration. Let's start by duplicating the previous example, disconnecting the old signal of the left button and removing the right button. Then I'll rename the HBox container to progress bar timer example, the button to start timer button, and the progress bar to timer progress bar. Then I'll also add a label to the progress bar that will display the timer. I'll name it timer label. put 0 into the text box, and set the anchor preset to full rect. I also put both horizontal and vertical alignments on center. Make sure to toggle off the show percentage property on the progress bar so it doesn't overlap with our label. Then I'll replace the hand icon of the button with the play button. Let's replace the script on the hbox container with a new one. First we need references to the progress bar and its label. Make them both accessible as a unique name and then drag them into the script. Then we also want an exposed variable for the duration that we can change in the inspector, and a normal variable that keeps track of the timer. Inside the process function, we need to decrease the value of the timer when it's bigger than 0. So let's write the process function, and inside an if statement with the condition timer bigger than 0. And inside that if statement, decrease the value of the timer by delta. Delta is a parameter that is passed along the process function, and it's the time between the last and current process frame in seconds. Then we need to update our progress bar value property with the timer value, and below that we address the text property of our label and change the text to a string value of our timer. Next, we need our button to start the timer when it's pressed. Let's connect the pressed signal from our button to our script. Inside the connected function, address the max value of our progress bar and set it to duration. We also set our timer to the duration. Now when we run the scene, it works, but the label displays many decimals, making it hard to read. To fix this, go back to our code, and inside the str function, we use the snapped function with timer as the first parameter and the value of 0.1 as the second. And if you run the scene now, it looks a whole lot better. As said earlier, there are many use cases for progress bars, and once you get the hang of it, you can make a progress bar that displays the level progression, which is currently tied to my mouse, or you can make these hover thingies, these ability cooldowns, a health bar, and whatever this thing is on the bottom. That's it for the UI examples and this tutorial. Once again, this Godot project is available on itch.io, so you can explore everything yourself, including things that I didn't cover in this video. Good luck, and I'll see you in the next one.